Hello, my name is Ryan Musselman. I'm studying agricultural systems management, ag econ, agronomy, and ag education.
Hello, my name is Dylan Kunkel. I'm studying agricultural systems management.
Hi, my name is John Farrar. I'm studying Ag Systems Management.
And I'm Mark Winning, and I'm Ag Systems Management and Ag Econ. Our project is the inexpensive bale wrapper.
Inexpensive is one of my favorite words, Mark. What's the driver? Why inexpensive?
Our project was spelled out to be, we wanted to make a bale wrapper that could be used in third world countries. So current alternatives out there are much more, are thousands and thousands of dollars to buy. So the idea was to make this as cheaply as possible, but yet functional.
Okay. So there's a difference between how much you spent to build this one and how much it would actually cost to make the next one just like it. How much would it cost to make one just like it?
What we spent was a little over $1,100. So well, I figure with some hours of band time in there and some markup for sales, $2,000 to $3,000 probably for this.
And still, somebody's making a profit.
Yeah.
Okay. So I see you got some AutoCAD drawings. Talk me through the major components of that.
Okay. The major parts of our system are the motor system, which we have a wheel motor because we can get very low speeds and high torque out of that. We've got that direct driven to the swinging arm here. And on the swinging arm, we've got a counterweight to balance out our roll of wrap, which is on this side. And the wrap has a tensioner system where we've actually got 2 plates of ultra high molecular weight polyethylene, clamping it down with the spring to give it tension so it stretches as it wraps. And then at the bottom of our main pole over here, which is hooked to a 3-pointer tractor, we've got a roller sticking back, which hits, we have the bale like this sitting on the ground, and we can just back into it with that roller and roll it along the ground as we're spinning the main arm around and wrapping it down.
Okay, so it seems like the current production models that are out there, they sort of have lots of moving parts. One part to roll the bale and the other part to wrap the plastic. In your case, it's really only one big moving part.
Yeah. Basically, we've got a set of bearings here, and then our roll there has a set of bearings. That's about the only moving parts we have on our whole system. So that should limit the maintenance necessary in the future and limit how much possibility of breaking anything there is.
Hey Ryan, show me this plastic tensioning thing.
All right,
How's
so
it work?
we have it's held on by a spool underneath, and then it has plastic on the bottom so it doesn't wear it down, and then plastic on the top, and then we're tensioning it with a spring, and then tighten it down, and then we can adjust it by changing the spring.
So why do we need tension?
Well, because it stretches the plastic, and so you don't use as much, and also it tight and seals it, and then it'll stick better that way.
By getting the pre-stretch right, it sticks to itself a little better on the bale.
Yes.
Awesome. Okay, so let's pretend I was the bale. If you're careful. So I'm the bale, and the plastic is stick to the bale, and then what happens? What moves? Go ahead.
Would you like to see it? This moves, and it just rotates around, and it'll wrap you tight, and then when you're done, just cut it off, and it's ready to be moved.
Okay, but if that goes around, all I'm going to do is get a belt. I want to wrap the whole bale. So how's that?
Well, that's why we push it with the roller.
This one.
Yeah, that pushes the bale forward, so you're backing up as you wrap it.
Is that the bale over there that you wrapped?
Yeah, that's the bale.
It looks pretty good.
Yep.
Somebody else poked a hole in it.
Yeah, we wrapped that last night.
It looks good. Dylan, I'm looking at a pretty large motor there, but man, that's simple. No chains, no belts. How does it just happen to work so magically?
That's why we chose this specific type of motor, is because it is high torque and low speed. Through the hydraulic system, we have a very simple connection. The motor itself actually holds the vast majority of the weight, which is also held by 2 of the bearings slightly. And through that, It's lower maintenance and it gives us the desired speed of the arm.
Okay. And how do you control the speed of the arm? Got
The
anything
speed
special
of
on here?
the arm is all through the hydraulics here. It can be controlled from the driver's seat. And that is more for RAR's department.
Oh, John, come in. Tell us how that
Swing
works.
it.
Well, what we've got over here is a pressure compensated adjustable flow control valve. So we can adjust the flow going to the arm and control how fast it's spinning around. And that's basically all there is to control the speed of it. It's a check valve to prevent the motor from running in reverse.
Okay. And you got a video showing
we've
us
got a whole
actually
video
wrapping the bale.
Showing it wrapping the bale.
Awesome. Let's go take a look at
All
that.
right.
Alright, so what you need to do for actually wrapping the bale is you back it up to the bale. You gotta make sure you're square and centered on the bale. When you get back to the bale, if you have two people, you could have a person on the ground that actually hooks the plastic to the bale. In this case, I only have one person, because the other person had to shoot video. So you pull the plastic off the roll a little bit, and we just tied it to the bale. I'm talking faster.
Weird hearing the air when you kick it on. That air,
And once you get that tied on there,
I'm thinking if Red Green did this, there'd probably be some more excitement.
you just start the spinning arm going around. The idea is to get it as centered as possible using the 3-point pitch. So you can raise up and down a little bit. And just back up slowly as you go.
Gradually roll the bale.
Gradually roll the bale along the ground. Keep the spinning arm spinning so it stays tight at all times. Get about 2 layers of wrap on each area, and then go around once like that, and go around another time, so you end up with about 4 layers of wrap everywhere.
4 layers of plastic at every spot on the bale.
Yep. So what we did actually is we unwrapped one of the bales after we finished wrapping it, measured it out. We had about 290 feet of plastic on it, but with stretch we figured we used about 230 feet of plastic. So for $90 a roll, it's about $350 that we spent per bale. So
About 26 bales per roll of plastic.
and then when you get to the end, you just hop back off the tractor, cut the plastic, and pull away. Get in the next bale.
Looks like an awesome solution. What university does all this kind of stuff?
Purdue University.
Oiler up.